online learning session of B.Sc Agriculture third semester course Biochem 231. Students, in previous class we learned about the optical isomerism and the Killian hypothesis of cyanohydrin formation, Killian hypothesis of monosaccharide synthesis. Both the part of Killian hypothesis, Killian reaction we learned in detail. In today's class we are going to understand the formulation and structure of carbohydrate, especially the glucose. The different interconversions are also we have to study in this class. Let us start today's session. Student, the formula, molecular formula, not only known for as a glucose but ultimate resultant product of different metabolic biological cycle and widely and popularly called as the food. So this formula is in front of you, C6H12O6, commonly called as the glucose, molecular formula of glucose, as well as known as designated as the food. The C6H12O6 is the molecular formula of the glucose and it represents the presence of 6 carbon, 12 hydrogen and the 6 oxygen atom, C6H12O6. The in detail configuration was not explained, hence the scientists Fitting and Baer simplified the molecular formula of the glucose and they have represented their own formula regarding the glucose, that is the Fitting and Baer formula for the glucose. This formula is in front of you, represented on the blackboard. The structure explains that the presence of aldehyde group and 4 hydroxyl group and 1 CH2OH group are responsible for formation of glucose. This Fitting and Baer formula further simplified by the scientist Hermann Emil Fischer, and he explained this formula as a Hermann Emil Fischer projection formula for the glucose. The formula is in front of you. This formula states that the presence of 4 asymmetric carbon atoms are responsible for formation of 16 different stereoisomers. How these different stereoisomers were formed, that we learned in case of Killian hypothesis, and in detail study we have to carry out in next class. This is the Fischer's projection formula for the glucose and widely accepted for representing different reactions and formulas for different monosaccharide, oligosaccharide and polysaccharide. The Fischer projection formula. Hermann Emil Fischer, one of the great scientists from Germany and known for his outstanding discoveries of esterification reaction. Then the formula which is in front of you, the Fischer's projection formula, the structure of asymmetric carbon atom and lock-and-key model of enzyme. Because of his outstanding contribution, he was honored with Nobel Prize. Students, the angle of tetrahedral carbon atom tend to bend the chain structure to form the ring. The aldehyde group present at the carbon number 1 or ketone group present at the carbon number 2 and the alcoholic OH group present at carbon number 4 or carbon number 5 are responsible for interconversion and to form the ring-like structure. The interconversion of aldehyde group of carbon number 1 and the alcoholic OH group present at carbon number 4 and carbon number 5 are responsible for formation of the hemiacetal in case of aldehyde and hemiketal in case of ketone group. The hypothetical reaction how the hemiacetal and hemiketal groups are formed, these are represented in front of you on the blackboard. Here the R1 plus CHO and the ROH, that is the first one aldehyde group, when reacts with the alcoholic OH group, then there is a formation of hemiacetal in case of aldehyde. Whereas in case of ketone group, when it reacts with alcoholic OH, then there is a formation of the hemiketal form. And due to formation of or interconversion or the intermolecular attraction is responsible for bending of chain structure to form the ring structure and commonly called as the pyran in case of C1 C5 intermolecular attraction and in case of C1 C4 called as the furan structure. The pyran structure is more stable as compared to furan structure and both the structures are represented in front of you on blackboard, the pyran structure. So here the pyran structure is represented in front of you and then after the chain formulation is also in front of you. In case of fluorine structure, the intermolecular attraction between carbon number 1 aldehyde and the carbon number 4 alcoholic OH group are the intermolecular conversion is there and to form the ring-like structure. The pyrene and fluorine structure are in front of you. The structures so formed are called as the distereoisomer. The distereoisomer, these structures look like same, but these are not the mirror images. These are also called as the anomer. Students, the formation of ring structure create the new center of asymmetry at carbon number 1 in case of aldehyde and at carbon number 2 in case of ketone group. The structure so formed is responsible for formation of distereoisomer. The structure look like same, but these are not the exact mirror images of each other. Hence, these are called as the stereoisomer, distereoisomer. These are also called as the anomer. Students, according to the suggestion given by the scientist Rodenberg in 1933, who stated that the anomers who form same structure around the anomeric carbon and the ultimate carbon that is present at the 4 or 5 carbon atom. The anomeric carbon means carbon atom present at first position and the ultimate carbon atom present at carbon number 4 or carbon number 5. Form exhibit same configuration, same structure are called as the alpha form, and when possesses a different configuration at the anomeric and the ultimate carbon atom are called as the beta form. Next, simplified form of carbohydrate glucose structure were represented by the scientist Hoover. Students, the simplification of glucose formula was given by Fittig-Beer, simplified by the Harmony Mill-Fisher, known as the Fisher's projection formula. The Fisher's projection formula then after represented through the ring form by the scientist Walter Norman Hoover. The Hoover, one of the great scientists from the chemistry and honored with Nobel Prize because of his extraordinary discoveries. The Hoover first time converted the Fisher's chain formula into the Hoover ring formula. The conversion of alpha D glucose and beta L glucose into the ring formation is in front of you, represented in front of you. Here, the structure of alpha D glucose converted into the ring form by the scientist Hoover. Then after the beta L glucose into the ring form. The representation is in front of you. This is explained by Hoover, that is the compound or group of compound, atom or group of atom represented at the right side and left side of the carbon, represented with the highlighting point at the upward and downward position in case of ring form. The hydrogen or hydroxyl group present at the right side of carbon in case of Fisher's chain formula represented towards the downward plane, written in downward manner, downward position, and towards left represented with the upward position. The exception is at carbon number 5. The exception is there, the hydrogen is represented at the downward plane as the represented here at the left, and the compound which is not participating in the ring formation is represented at the upward position of the ring formula. Scientist Hoover represented the conversion of chain formula into the ring structure with certain assumption. The first assumption given by the scientist Hoover is when the H and OH present at the right side of the carbon in case of chain represented written at the downward position, and when towards left represented with the upward position, except carbon number 5. Hydrogen is represented at the downward of the plane. Number second assumption number second, the compound which is not participating in the ring formation is represented, that is carbon number 6, at the upward position of the plane in case of ring structure given by the Hoover. When the Hoover converted the Fisher's chain formula into the ring formula, it becomes very easy to represent the tedious and complicated reactions of carbohydrate in easy and simplified manner. Next assumption given by the Hoover, that is, instead of representing the H and OH, the only highlighting line, the bold lines represent the presence of the hydroxyl group. Presence of hydroxyl group, and the CH2OH, that is carbon number 6, is also represented in case of the ring form. The further modification made by Hoover in his ring formation, and the structure is represented in front of you. The presence of hydroxyl group in case of the chain formation is represented in case of ring formation, and the denomination or representation of hydrogen is avoided. This is the modified structure given by the Hoover. This is called as the Hoover ring structure, which is represented from the Fisher's chain projection. This is the in detail information about the formulation and structures of carbohydrate, especially glucose. If you are really benefited by this video, like this video, share this video among the students, those who are in the third semester of B.Sc Agriculture course, and you can follow me on Facebook, Instagram and WhatsApp. Personally, you can share your difficulties on WhatsApp number 9421872858. You can mail your difficulty through atulebondwe@gmail.com, or you can share your difficulty on your Google Classroom or YouTube comment box. Thank you.